Hi everyone, welcome to today's webinar. We're going to go ahead and give 2 more minutes for grace period. We know a number of folks are coming out of meetings, so we'll give it those 2 minutes and then we'll get started. Thank you. Hey everyone, for those of you that are just coming in now, we're going to give it 1 more minute. We're going to let folks get out of their current meetings, give a little grace period. So just hang on tight, we'll start shortly. Thanks. All right, hi everyone, welcome to today's session. We'll go ahead and get started. We gave a little 3-minute grace periods for folks to come in. We know folks are coming out of other meetings, but with that, let's go ahead and get started for today's session. Hi everyone, my name is Jose Barajas. I am the Technical Director of North America for the Sales Engineering team here at AttackIQ. And today we're going to talk about comprehensive adversary emulation. The main focus of today is going to go over one of our new key features that we're releasing here at AttackIQ, the anatomic engine. This anatomic engine lets us invoke attacker behavior in a very special way, which we'll cover here today. What we'll go through today for the purpose of the demo and the agenda for today will be, first and foremost, I want to start off with an architectural review. Want to walk you through how the product functions and works at that level. After that, we can talk about continuous security validation. For those of you that have seen our demos in the past, this has been the key focus of a lot of our demos recently and the one that I gave last. So we'll go over that concept and then talk about comprehensive adversary emulation itself. What's different about that? What are the different questions that we're asking and the different capabilities that this type of testing provides? And then finally, we'll get right into the product and do a product demo. Walk you through the process of actually invoking one of these anatomic engine graphs, showing you what the outputs look like. And we'll even show you how you can build your own as well. One of the key items here at AttackIQ is our open architecture. We want to make it extensible for everyone that works with us. So we'll show you how in this new key feature, you're going to be able to build your own as well. That's what I have planned for today. What we'll do is we'll leave a few minutes at the end for any questions. So please do ask questions along the way. If I see them, I can answer them as I go. If not, we'll go ahead and answer some of those questions towards the end. All right. So to start, let's take a look at the AttackIQ architecture and how it works and functions. To start, in the middle, we have the management web UI. This is essentially a Chrome browser that you use to access the platform itself. Once inside of the platform, the first thing that you're going to do is download our agents. Our agents are extremely lightweight. We can say that because 1, they do not hook into the kernel. So that concern that I know some of you may have is not there. And secondly, we're not a protective capability. What that means is we're not constantly doing work like, say, an EDR needs to do in order to protect. your environment, we're simply sitting there passively checking in, and whenever these agents have a job to do, they'll go ahead and do so. What I want to note about these agents is these agents communicate outbound over port 443 to the platform. They don't listen or receive any communication. And these agents are there to facilitate invoking the attacker behavior in a safe, do no harm fashion. Anything that we do will have a cleanup phase as part of it, and is why we can run in production today. As I go through the demo, do note that functionalities of the product are available via REST API. So any programmatic workflows or items that you want to automate with our product is absolutely possible. Other than the agents, there's one more component that we do need to install. With the agents themselves, we can actually go ahead and invoke attacker behavior, get an understanding of what's prevented within your environment, and the response from your security technology does not change if we don't have the integration manager. What the integration manager facilitates is after the agent has done its work, it's going to go ahead and query security technologies in order to verify that they responded adequately. To that point, you'll see in my demo today, I happen to have CrowdStrike and Splunk, one of our many partners as part of the Preactive Security Exchange. And the integration manager will, as part of a process, query the security technology directly, ensuring that detections are found as expected. After that's complete, we'll then query the source type within the SIM, in my case, Splunk, in order to verify that that context was appropriately forwarded to the SIM. We call that validating the security pipeline, and we want to ensure that all your expectations from that perspective are actually being met. And the integration manager is going to help facilitate that in a programmatic fashion. That's essentially our AttackIQ architecture. So let's go ahead and talk a little bit more about continuous security validation next. For those of you that have attended our previous webinars or have seen some of our work, these are some of the questions that we want to answer as part of establishing a continuous security validation process within your organization. The key question being, how effective are my security controls today, specifically in the context of your production environment, and then the context and features and capabilities within your security technology. As practitioners, we have an expected capability for each of the technologies that we manage today, whether it's through policies, whether it's through custom rules, or maybe analytics that we've written. By proactively exercising your environment and replicating known attacker behavior, we can help answer the questions of whether your expectations are being met. Now, beyond this, and I personally really care about this piece, as a researcher for over 10 years, one of the biggest things I've learned here at AttackIQ is that I could have created analytics and policies that could have prevented my customers, against everything in the world. None of that matters if the technology is not appropriately configured and if the process is not adequately meeting the expectations of the business. So from that perspective, the other question that we answer as part of engaging in this continuous security validation process is, how effective is my process? Is my security pipeline working appropriately? With the example earlier from an architectural perspective, if your team is only looking in Splunk and that's where the source of truth should be, let's make sure that that's actually working effectively. Let's make sure that all of your security technology are sending context there. Beyond this, is the context that's actually showing up in these systems adequate context for the analysts to understand what occurred, to understand that their technology that they expected to respond actually did so? These are the kind of things that we can answer with continuous security validation and by exercising our environment. Now, as we move into the concept of comprehensive adversary emulation, slightly different questions will be asked, and I'll show you how we can answer those in the demo today. The first question being, how would a known attacker intent play out in my environment? Through projects such as the adversary emulation plans that the MITRE Center for Threat Informed Defense has released. As practitioners, we have some good guidelines on what the attacker intent is, what is their typical MO, and in what order do they actually operationalize that context. With that in mind, the type of questions that we can help answer and try to understand is at what step in the attack would my security program mitigate this known attacker behavior? Again, things like FIN6, MenuPass, and APT29 are items where we have some emulation plans that the community has provided for us to look at and compare within our environments. Beyond this, the other question that we can help answer with this type of testing is what direct effect does a given policy have on the attack? This can go both ways, right? What if I disable this policy because it's interrupting a business process? Can I get away with, eliminating this policy, but still having the controls that I expect out of my environment? The flip side of that I see other organizations struggle with the most is enforcing something that is not in place today. The concern being is how will this affect the business process? How can we ensure this is not going to interrupt our business? So from that perspective, we can start to showcase to our organization what the impact of not having this policy is, and we can actually weigh that against the business issue that it might cause. The third item that we'll get out of this is how much context do my security tools provide to help me understand what occurred? While individual actions and specific TTPs are some of the things that we were looking at previously, we can now look at it from the context of the entire attack chain and get an understanding of how does that context align with what was played out as part of this process. The other portion that we've seen a lot with our customers today and why this capability has been released is how can I tune my technologies for effective alerting? One of the things here that we'll get out of going through this process is my technology able to intelligently alert me based on context? Concern being here is the constant alert fatigue that we all know and hear about, and ensuring that not only are we not alerting when we shouldn't, but making sure that we're alerting when, as a group, we should actually be taking action and respond. The other pattern that we've observed is through either SIM or even EDR technologies and others on the network side as well. The product themselves are providing ML engines. And at the same time, as analysts, we're being exposed more and more to some of these algorithms that we can apply to the data sets that we have within our SIMs, as an example. By using these tools, we're able to create new rules using these algorithms. And by going through a comprehensive adversary emulation, we can start to exercise and tune those rule sets to ensure that the expected outcome is being provided. Okay. All right, so with that, let's jump into the fun part and actually go through the demo and actually show you our new method of executing behavior with our anatomic engine. Here, what you see is our AttackIQ dashboard. This dashboard is actually informed based on the assessments that we select. So every customer and every user is able to define this within their environment so that they can focus on the key areas that they care about or that they manage themselves directly. We can look at things from the perspective of prevention and detection, but for the demos of today, what we'll do is we'll start off by running one of our attack graphs. Specifically, we'll run the APT29 attack graph. I'll show you what that looks like, what's different, and what the expected outcomes are. After that, we'll take a look at an attack graph that I ran, that same APT29 one, so you can see what it looks like when it's executed and the type of context that we're collecting along the way. Finally, we'll take a look at how we expose builders so that you can actually build your own attack graphs yourself. From this perspective, AttackIQ is going to constantly release new content, not only with the adversary emulation plans, but new behaviors as we observe them in the wild. But beyond this, as you have a certain rule that you want to write, this is going to give you the ability to create a matching test to ensure that if these 5 things happen or these other things occurred, the expected analytic would fire as expected. With that, let's go ahead and just dive right in and take a look at our template library. The template library is where we have a number of templates predefined and pre-configured for a variety of different use cases, whether it's testing that our baseline configurations for EDR are working as expected, whether we want to understand how much coverage we have against an active threat, or in this case, if we were to execute the known APT29 behavior, how would my environment respond? So let's go ahead and take a look at this attack graph and invoke it within our environment. And what I'll do instead is I'll actually open up the one that we're going to look at that I previously ran. And that one is right here. So to start, the attack graph engine or anatomic engine is here to provide our customers with the ability to get an understanding if known attacker behavior occurred, what is our ability to actually mitigate it? How far along would the attacker get? At the same time, one of the other things that we want to introduce is assuming that the attacker tried some alternative procedures, what is our ability to actually notice those alternative procedures and mitigate those as well? So let's go ahead and take a look at what's going on here. This attack graph, what it's doing is it's actually creating a new process. And what we're going to do is we're going to try to generate these different TTPs as we move along in the process. So starting off with a rapid collection of files, anything that we find, we're going to try to exfiltrate it to start. After that, what the attacker does is it continues down its path to try to better understand the environment. So with that, we'll go ahead and do bypass UAC and see if that's possible. Along the way, we'll let you know how far along an attacker would be able to get in this type of situation. As we move along, one of the key features and capabilities here is actually capturing the intent of the attacker. In this case, when we get to the phase where we're attempting persistence, one of the first things that's attempted is going to be creation of a new service. What we've observed based on the research that's been done in this space is that if an attacker is prevented at this stage specific to APT29, they're going to go ahead and try something else. In this case, persistence through startup folder. If that's not successful, they'll try persistence through WMI. What this specifically allows us to do is to give you that context and understanding of where would this be prevented and which attack path in this case would be successful, leading us to finally doing some exfiltration. Now, going back to the beginning, what I also want to note is that the reason that we built this out in this way is it allows our customers to also test how this behavior, as it's collecting context and details, how does this eventually hit a certain threshold where the analytics on that local agent that's running, that's doing a little bit of ML and AI, to use those buzzwords, how far along is it going to get? How much context is necessary before it stomps on our process and kills it outright? Essentially, it's determined that the behavior that's being generated here is not normal. So let's go ahead and kill that process. This is the way that we've allowed our customers to now test and invoke behavior within their environment, so that rather than having to write this in Python code, as an example, if they want to write a custom attack chain, they can now do this in this new abstracted fashion. We even give you the ability to create your own as well. We'll go ahead and take a look at that in a moment, but before we do, let's go ahead and take a look at what the results look like for this assessment that we've ran. This is actually one that I ran here this morning just prior to going through this process. So let's go ahead and take a look at the results. As we can see, I have two assets here. Two of them actually prevented them, one of them did not. So let's go take a look at what it looks like in this first asset, and then take a look at where it was prevented. What you're looking at here is exactly the behaviors that were invoked as part of this process. And in this case, from one process instantiation, we're starting with the rapid collection of files all the way to the end where we were able to dump credentials successfully. In this case, we can actually see, because we do have integration with this technology, that this asset is not actively monitored by any technology. So it makes sense that in this case, where we're successful in making it across the entire attack route. One of the things to note is we did not have to use any alternative procedures. The ability to create a new service was there, so we went ahead and used that as a basis for persistence and moved on to the next step in this example. If this were actually mitigated here, we would have tried some of the alternative procedures as part of the process of this attack graph. Now, while we're looking at things at a high level, we are collecting context along the way. For every single action taking, we're highlighting the exact behavior and exactly what was found as part of a process, so that that full context and details that as an analyst you need to understand what occurred, and most importantly, how to mitigate this behavior is provided. And in cases like this, we can show the exact type of credentials that were found and the details along the way. Beyond this, every single AttackIQ scenario is going to provide you with mitigation recommendations to help you understand how you can actually implement some kind of control, implement some kind of policy in order to affect the outcome as part of the next run, and get an understanding of this is how I can mitigate this at this stage of the attack. We're looking at the last step here. We'd probably want to focus on something closer to the start, such as maybe blocking creation of these keys with something like bypass UAC. All right, so with that context in mind, this is an example where we have an asset without protection. Let's take a look at what happens when we actually run it with a security technology that we have in place next. In this case, you can see that first and foremost, the technology is actually running and installed. So from that perspective, we can see those details. And we can see that the attack was actually stopped at node 4. As we go through this process, we can observe exactly what occurred at every phase. And we take a look at something like discovery script, we can get an understanding of this item specifically being detected. From this perspective here, we can also have verified that that context ended up in Splunk as well. Again, now that was the third node. As we get to the fourth node, we can observe that this was actually prevented and that we actually have some detections in place as well here as this example. The question now for you as an analyst is, by going into the Falcon UI, we can get an understanding of how was this alerted, where did this alert end up, did this context end up in my SIM, and are there any policy changes that I can make to maybe stop it sooner in the process here. These are the type of questions that you can now answer and understand by actually executing in this new modality, which through our anatomic engine, that essentially is executing this behavior within this environment. Okay. All right. Now, beyond these, this example here for APT29, AttackIQ is going to continue to deliver other specific attack graphs for new attack groups. But at the same time, we're also giving our customers the ability to create their own. So let's go ahead and take a look at that next and show you how, like with anything else, we want to be an open platform and allow our customers to also build on top of our capabilities so that our community can benefit from that as well. So to that end, we actually give you the ability to build a custom attack graph yourself. And let's take a look at that next here. The important thing I want you to note as we go through this next phase of the demo is, first of all, the ability for you to create your own set of attack chains or attack graphs. Essentially tell us exactly what you want to recreate and allow you to actually capture the attacker intent within our framework. So let's go ahead and create this here. So in order to start off an attack graph, we can go ahead and simply add our first node. In this case, we can search for a specific MITRE category discovery and select a specific item here, such as process discovery through task list. By selecting that scenario here, we can actually go ahead and configure it as expected. We are even able to include things such as time delay as well. And I'll go ahead and do a time delay of about 25 seconds here. With that, we have our first node. One of the other key features that I want to mention as we go through this process a little bit further is, first of all, you have the ability to fully define how long you want this process to execute. So if you want to time bound the behavior, that is absolutely something that you can do. And as part of a tuning process, if as an analyst you want to understand, that's great that I'm stopping at a node 3 or 4, but I wanted to understand what would happen assuming the attack continued anyways. What would be my ability to prevent it, detect it, beyond the node where I stopped it today. This is why we give you the ability to actually run all and just go ahead and continue as part of the tuning process. Now here we have a simple one node item. I actually prepared another one that I want to show you so that we can actually build out our own assessment as well. And let's go ahead and take a look at that. So as you can see here, I've already built out a few more. I didn't want to bore you by adding a number of these items. But let's go ahead and build out and show you what we're actually doing here. So as you saw in the previous tab, I started off by a simple process discovery through task list, and I went ahead and added a few more items as well. Two follow-up items are account discovery, and then followed by system network configuration discovery through WMI. What I'm trying to recreate here is a number of different discovery items leading up to exfiltration, and depending on the results leading up to credential theft. The idea here is that we might be creating an ML rule that, if a simple process discovery happens, we obviously don't want to alert on that. That's probably benign and it's probably happening across the organization for a number of legitimate reasons. However, if additional things such as account discovery, network configuration discovery, and any other items that you may want to include as part of your expectations for a new analytic, you can start to build this out within your environment. So what I have here already built for you are two things. First of all, we're going to start off with process discovery. Then we're going to go ahead and attempt account discovery. And then finally, we're going to go ahead and do discovery through WMI. Now, in order to tell the attack graph what to do next, we can say if this is not prevented, let's go ahead and exfiltrate that information here next. Excellent. Now, one of the things that we also allow you to do here is to define what happens if it's not prevented, or if it is prevented as part of an example. In this case, we're able to define that intent as well. So in this case, if the attacker is not able to successfully obtain discovery through tasks, we don't want to end the attack graph here. We want to go ahead and try to do account discovery as well. After account discovery is attempted, we're going to try to do enumeration to WMI. The intent that we're allowing you to capture here is the attacker is going to continue regardless of whether he's able to get contents or not, because one of these actions for discovery is going to be successful. And in this case, with the final one, we want to feed that right into our first exfiltration piece, which is actually going to use command and control channels in order to exfiltrate the data that we've captured up to this point. Now let's go ahead and show you how we can set up some alternative procedures here. I've already done the legwork here, but let's go ahead and try to set up a final component where we're going to try to steal credentials. So let's go ahead and do that here. And what I'll type, we can type in this case by technique ID. And I'll just go ahead and select, dump password using losange is one of my favorite. We can select that one there. We can select next. Since no configuration is required. What I do want to note, if we want to use custom flags, you can absolutely add custom flags with any of these software tools that we have within our platform. For the purpose of the demo, I'm just going to go ahead and continue as is here. Finally, we can define a time. I'm just going to put 10 seconds here for the purpose of the demo. Now, so far, let's go ahead and repeat where we're at and show you what I'm going to build out next. We're going to start off with process discovery through task list. Regardless of whether we're prevented or not, or the process killed or not, we're going to try count discovery, followed by discovery via WMI. That context will then get followed up by an exfiltration piece, which we're going to want to go ahead and after that, actually execute losange to try to see if we can successfully steal credentials. So this is an example where we actually have this decision point and we can take the adversary's perspective. In this case, if exfiltration via command and control is successful, let's just go ahead and dump the losange, our credentials using losange is what we're codifying here through this process. Now, what we want to say is that if it's prevented, in this case, command and control over command and control, then let's actually go ahead and try to exfiltrate the data via email instead. And if this is not prevented, let's go ahead and move on to the dump password piece next. And again, here we have yet another two examples where assuming that email is prevented as well, we'll go ahead and try via DNS, and then finally we'll try via HTTP. What this allows you to do is by codifying this context, we can actually go ahead and recreate the attacker behavior. So let's go ahead and then add this one here to kind of finish off the attack graph in this process. So as we can see, by simply adding a few of the scenarios within our library, we're able to allow you to then say at each of these nodes, what is the action that I want to take next? As you're reading threat reports, you may want to capture the intent of the attacker through these processes. At the same time, there's a specific item that you've seen or observed that you want to recreate and ensure that your analytics would identify it as corrected, as expected, collect the right context, and inform your team in the right way. This is going to allow you to actually plan out and do that within the environment. The final piece that I want to note is that as we go through and build this out, the entire scenario library within the AttackIQ platform is available to our customers today. So if we go and take a look at that, the AttackIQ platform has extensive coverage of the MITRE ATT&CK matrix tactics, techniques, and procedures. From this end, customers can filter based on a variety of different factors, whether it's the MITRE tactic, whether it's threat actor techniques that are known, ransomware, or even threat intelligence feed as well. This entire scenario library is available via the attack graph engine so that you as a customer can build these out, recreate known attacker behaviors, or even create some test cases for some analytics that you've written within your environment. All that context is going to allow you to create assessments such as this one. Assessments such as this one, where we can actually get an understanding of how effective is our security controls in identifying the attacker behavior. If we start out with something like this, what can we do to actually affect it from a policy perspective to end up in a better situation such as this one? mitigating the attack early on in a situation where we're creating very suspicious behavior, and where this context has actually helped elevate this to the point where an alert is generated and maybe it's being identified as a known attacker attack group given the technology as well. Cool. So yeah, that's all I had from the perspective of the demo with the product today. We can open it up for questions next. Let's take a look here. We have a few. Cool. All right, so we do have a few questions here. So for one, someone is asking us, AttackIQ, something that they found in the AWS marketplace. Absolutely reach out to us as a team, and we can absolutely provide that context to you. Now, the other question here is asking us, can the platform work on testing containers platform in EKS? My answer to that is, and what I mentioned in terms of our agent being extremely lightweight, we don't hook into the kernel. So what that means is that we can run in a containerized environment, such as an Ubuntu Docker container, from that perspective. So that's how we can potentially function in that work. Another question is, I'll go ahead and put up the MITRE ATT&CK framework slide as well and show that. And in this case, this is actually being informed by the assessments that we've highlighted and showcased there. So I'll put that up for the folks that want to see that. The last thing, okay, cool. Yeah, so in terms of the, got it. So we have a question here about, the process and how it works, how this might work with multiple hosts, and how it might start to automatically learn some other items. It's, for example, if bypass UAC is being blocked, what can we do from there? I think that there's kind of two questions or two answers that I can provide to this here. So for one, that's exactly what we're providing, the capability for you to define an alternative procedure. If bypass UAC is not a method that is successful for escalating privileges, we can actually define define what the alternative procedure should be ran as part of that process. And then the other part is, how are we actually able to get away with this without specifying the hosts in the graph? To a certain degree, the hosts are already defined. We're instantiating the behavior on machines that have our agent. So from that perspective, that agent can actually collect the local information, can do a scan as an example, and capture dynamically hosts that may be targeted as part of the next step. So that's how we're able to get away with that. I have another question here. That's why it threw me off a little bit. The first question said ICT matrices. Wasn't sure what that meant. I think what they meant was industrial control system. So from that perspective, we do have some techniques that are covered from that perspective, and the team here at AttackIQ has submitted some content from that perspective as well. We've also given talks on doing some threat intel processing with Modbus DMP3 protocols. And this is something that we're able to facilitate through our custom scenario development. And some of those items we obviously support directly as well. But that's how we're able to address that. Let's take a look at the next question. Okay. So the other question is going to be around historical trends. So we absolutely have the ability to track what the results have been and what they have been over time. So let's see if I can pull up an example here. I'll show an example here where we do have some results and results over time. The example that we went through today, I don't have examples for that one specifically, but as you can see with one of my other assessments here, we're absolutely going to be able to highlight down to the individual tactic, technique, or procedure that's invoked as part of the nodes and the graph that we just ran through, the ability for you to understand what those results have been and what they have been over time. What we're highlighting here is, the blue line is going to be the detections over time. The yellow is going to be the preventions over time. So it's something that we absolutely track for you and are able to even provide you some diff reports that are going to provide some context there. Beyond this, we actually do provide you the ability to track your results and specifically track them over time, so we can see in a comparison with a given date how well we're doing and how we're configuring as well. Okay. I have another question about, do the nodes are able to pass data to each other? And they absolutely can. So to the question earlier about how do you know what to target, we're able to pass some of that context so that we don't have to define everything specifically. Of course, we do give you the option to bound things as well. That's typically a follow-up question, right? If we do an Nmap scan, you don't necessarily want us to target the entire environment. So I do want to note that throughout the product, we have customization so that you can say, I only want to target specific assets, so you can bound it from that perspective as well. All right. I got another question here about special subscription or capabilities for the academic users. I'm assuming this is about AttackIQ Academy. What I can say to that is, and this is what I wanted to end with, I'll answer a few more questions with the time we have though as well. We actually have an Academy course that's being released here shortly in the next week or so. What we'll do is teach you in more depth than I could go in today, how this attack graph engine works, or anatomic engine works, how you can leverage it within your environment, and we'll actually give you hands-on experience building it as well as part of that course. For those of you that don't know, you can go to academy.attackiq.com and sign up. Those are free courses for anybody. You don't have to be a customer or a prospect, and you also get CPE credit as part of that process. Okay. Another question is, how does AttackIQ emulate attacks against an AI training algorithm? So from that perspective, what we can do is there's two components to that. So for one, we're able to, through this anatomic engine, invoke the behavior in specific chains or steps. We're also able to define those alternative procedures and capture the attacker's intent. So from that perspective, by running those attacks, some of our customers that are doing AI training today, what they're using is they're using the raw data that's being generated as part of that process. So as we're running attacks, we're generating context, and they're building ML and AI engines based on the raw data set themselves. Or through technologies like SIM, they're starting to provide them some AI rules that they can develop, and they can actually use those mechanisms to see how they can better create some of those algorithms or rule sets that use AI algorithms to better understand the attack. Now, there's another part of that as well, which is as part of training in AI, you want to be able to understand what is, what is true and what is not, meaning what is a real attack and what is AttackIQ doing. To that end, we have a process through we call it a SIM forwarder. So we can forward context to a SIM so that our customers that are doing this today, they can take that context and then remove that, those results that are known to be AttackIQ in comparison to those that are actually within their environment. This is something that we simply facilitate via our API. And if we go into the details of one of our scenarios, as an example, we're capturing very, very detailed output of exactly what occurred. And that context is going to help ensure that as they're training those AI engines, they can actually remove some of that context from their data sets if that's something that they need to do as part of their process. I have another question here. How many agents are typically deployed? Our recommendation, I always like to say a rule of thumb is anywhere from 5 to 15% of an organization's topology. That's just a rule of thumb. What we do is we have a process we call the assessment design workshop. What we can do is we want to understand your environment. What technologies do you have in place? What controls do you have? And what are your crown jewels? Based on that context, what we're going to do is we're going to go ahead and actually exercise your environment, based or define where we deploy the agents based on that context. So if you're managing different offices with unique boundaries, we definitely want to place agents there. If we have network segments and operating system builds within those systems, let's make sure we have some representative sets. And for those of us managing a forest of domain controllers, let's make sure that every protection failure at that, within that domain controller is actually covered. I've been able to find entire segments of a business that don't have basic AV installed. So from that perspective, this is why we want to proactively test in this manner. Let me see here. Another question is, can you expand on how we can use AttackIQ to test web apps like Burp? This is an area where our customers can take some of our scenarios today and customize them to fit their what they want to test today, or even take some tools for the most advanced users. Since Burp is being mentioned here, you can actually use our framework to invoke capabilities through Python. That's a little bit more advanced use case for those that are trying to automate those things, but we can absolutely do that. So the other question is, can I have a AttackIQ platform on my own premise? And do you have to pay for professional services? So there's kind of two questions there. So first of all, the AttackIQ platform by default is a SaaS cloud. However, we do offer on-prem down to completely offline installations as well, if that's a requirement. So absolutely, we do support on-prem. Any custom scenarios that you built, whether on-prem or in our SaaS cloud, are not going to be shared with anybody else. They are yours and yours alone. With that in mind, we do absolutely have a community built around this product. So if it's something that you think the community can benefit from, we would absolutely, would like you to provide it to the community. Our scenario team will actually look at what you've provided, clean it up for the purposes of including it within our framework, and then make it available to our customers at large. So you can kind of have it both ways. At the same time, we do have professional services. So customers that do want us to maybe write some custom attacks for them, this typically is going to be with very proprietary systems where, is when we have a need for something like that. And we can absolutely support that as well. There's two more questions I think I'll answer here, given our time. Is the APT29 attack graph a template which I can use as a base, or can I only use the custom attack graph template? So no, the APT29 is, and the others that we have are absolutely available to you, but you also have the custom template that you can build up on. I have another question, more of a business question as an example. We're not going to charge you per scan. That's not how we operate and function here at AttackIQ. You can send me a question, Jose@attackiq.com, or email us at sales@attackiq.com, so you can get a better understanding of the pricing model. But yeah, we're not going to charge you for every single run within the platform. That's just not our model here either. I'll answer this one last question here. Is this one integrated with Microsoft Defender ATP? Absolutely. Microsoft Defender ATP, along with CrowdStrike and Splunk, which you already saw in the demo today, are all part of our pre-active security exchange. So we absolutely integrate with Microsoft Defender ATP. And to that end, if you happen to have Azure Sentinel as well as part of that offering, we support that SIM too. So that want to mention that here. All right, team. Any other questions? We have one more minute. Really appreciate all these questions. This is great. All right, no more questions. Going once, going twice. Awesome. Well, with that, team, I appreciate your time today. This was just a short introduction to this new concept of our anatomic engine, where we can actually invoke, attack graphs in order to replicate attacker behavior. For those of you that have any additional questions, please feel free to reach out to me directly, Jose@attackiq.com. Simple enough to remember. But at the same time, if you want to learn more, if you want to get hands-on with this feature, go to academy.attackiq.com, and you can sign up for a course that's coming out here in the next 2 weeks that actually gives you a cyber range where you can actually create these attack graphs and invoke them yourself. All right, appreciate everyone's time today. Have a good one.